In today's video, we will be looking at the concavity of a cubic function. Now, in order for you to know the concavity of a cubic function, you need the x value of your point of inflection. How do you find the x value of your point of inflection? If it's not given on the graph, you will then have to find the second derivative of your f of x, equate it to 0, and then solve for x. How do you find the x values of a turning point? Well, you would have to find the first derivative of your cubic function and then equate it to x. I'm kidding, you equate it to 0. How do you find the x value of this specific turning point? Well, first derivative equated to 0. Alright, beautiful. But in today's video, we are not doing turning points. Ours is to work with the point of inflection. Now, for concavity, your point of inflection actually changes where concavity is. Now, if we drew a vertical line that passes our concavity point, from face value, you should know that if you have the frowny face, the frowny part of your cubic, that will give you concave down. The smiley part of your cubic will give you concave up. So just by looking at this, here we have the frowny face of our cubic. So we have concave down. And this side we have the smiley face of our cubic. So we have concave up. Let us say we were given an x value at the point of inflection. Let's say 1. Now for concave up, x would be bigger than 1, and for concave down, x would be smaller than 1. Remember, concavity plays a hand and a role with the x value of the point of inflection. Let us try the next example. We are given a function and a graph. G of x is our function, and here we're given a graph. Now the x value of our point of inflection happens to lie on the y-axis. What do? We draw a vertical line. From face value, we know that the frowny face part of our cubic will be concave down, and the smiley face part of our cubic will be concave up. In order to answer that, well, for concave up, x should be bigger than 0, and for concave down, x should be smaller than 0. Let us look at another example. We are given a function here, h of x, and his graph. The important thing is to identify your point of inflection, and our point of inflection is given where x is equal to -3/2. What we need to do is draw a dotted line for ourselves, and we know concavity changes at that point. Now from face value, we know that on this side we have a smiley face part of our cubic, so that would be concave up, and on this side we have a frowny face part of a cubic, so that'll be concave down. Now we need to write this algebraically. For concave up, x should be smaller than -3/2, and for concave down, x should be bigger than -3/2. We always use the x value of the point of inflection. Let us try the next example. In this case, we are not given a diagram. However, we are given a complete function. How do you find concavity and how do you test concavity? Well, we need to find the second derivative, meaning we need to find the point of inflection. The first derivative would be 3x squared plus 24x. The second derivative would be 6x plus 24. Now, in order for you to find the x value of the point of inflection, you need to equate this to 0. Therefore, we have 6x plus 24 equated to 0. If you take 24 to the right hand side, you have -24. If you solve for x, we have x is equals to -2. That gives us the x value of our point of inflection. Now, can we actually draw this guy? Yes, we can. If we draw a rough sketch without the turning points, because we don't need the turning points here, the only thing we do need is the point of inflection. How do we know how our cubic function will look like? You need to remember that the a influences how the cubic function looks like. So if a is bigger than 0, if a is a positive number, meaning bigger than 0, you have an increasing cubic. And if a is a negative number, meaning smaller than 0, you have a decreasing cubic. Here, our a happens to be +1, and +1 is bigger than 0. So we will be using an increasing cubic. The x-intercepts do not matter here when working with concavity. What matters is the x value of your point of inflection. Now, our point of inflection would be at -2. Let us draw a vertical line that crosses -2. From here onwards, we can actually draw our cubic function. This is a rough sketch of our f of x with the turning point being at -2. From face value, we can see that, well, for concave down, since this part is a frowny face, concave down would be here. And on this side, we have the part of the cubic, which is a smiley face. This would be concave up. Remember, the part of the cubic function, which is a frowny face, we have a frowny face here, that's concave down, and the rest of the other part of a cubic function, which is a smiley face, that would be concave up. How do you write it algebraically? Well, x for concave down should be smaller than -2, and then for concave up, x should be bigger than -2. We always use the point of inflection to speak about our concavity. Let us look at the last example. Here we are given h of x equals to x cubed plus x. Again, how do you find concavity? Well, you have to derive twice. Our first derivative is 3x squared plus 1, and then our second derivative would be 6x. Equate your second derivative to 0. If we do that, we get our point of inflection, and our point of inflection here would be 0. Can we draw this guy? Of course we can. Let us just find out how our a is. Well, remember, if your a is bigger than 0, meaning if it's a positive, you have a function that's increasing, so it can either look like that or it can look like this, a cubic function. If a is less than 0, meaning a negative, you'd have a decrease in cubic, so it either look like this or it look like this. Here our a is 1, meaning we have an increasing cubic. Let us draw a rough sketch of our cubic. Label your axis. We know that this kind of cubic is an increasing one which has only one root, and since the root is where the turning point is, how many roots does it have actually? Let us test it. The x intercepts of this would be x cubed plus x. Take out x as a common factor. You have x squared plus 1. That means that x is equals to 0, or x is equals to -1, and there's no way that you can get a square root of a negative, so the only intercept it has is at 0. Let us draw it now. That's our cubic function. Now, remember, your point of inflection happens to be at 0. In this case here, we need to test for concavity. How do you test for concavity? Well, you use the second derivative formula to test for concavity. Draw our sine line. Use the x value of your point of inflection. In this case, it's 0. And then sub in values on the left hand side of 0 and then on the right hand side of 0. Sub in values into the second derivative. If you sub in -1, well, 6 times -1 is -6. If you sub in +1, well, 6 times +1 is +6. So on this side, we have concave up, and on this side, we have concave down. Thanks for watching. See you next time.